Welcome to the 20th video in the Metric Math Water Wastewater YouTube series. Today's video is going to explain how to find the accuracy of a meter. This would then be useful later in calibrating a meter. What we're going to look at today is trying to figure out how close a meter is reading in comparison to the actual numbers that are going by. For example, if your speedometer in your car reads 100 kilometers per hour, but the photo radar gun says you're going 110, well, obviously you've got a little bit of a margin of error in terms of the accuracy of your speedometer. Same thing here when we're talking about any kind of meter that is being used, whether it's a dosing meter or whether it's a flow meter or it's any type of a meter, you have to be able to determine how accurate it is. Now again, the accuracy of a meter is always a comparison of what it's reading to what actually is the volume or the distance of the material that is being read by the meter. For example, when we take a look at the percentage accuracy, we want to determine how close the meter is to reality. And the formula for that is experimental, or what the meter is saying, compared to the reality. What we know for a fact is an actual number. And then you multiply that by 100 to find your percentage accuracy. The example that we're going to look at today is a water meter is tested in a lab. The meter reads a flow rate to be 8.2 liters per minute. However, the known actual flow rate was found to be 8.9 liters per minute. Find the accuracy of the meter as a percentage. So when we look at these numbers, we have to determine a couple of things. First of all, what are the key words? What does the meter say was the flow rate in this situation? Now, in this case, it was 8.2 liters per minute. Now, what do we know is the actual, the factual? We know for a fact. What is that number? Well, that was 8.9 liters per minute. So now what we're asked to find, what is the accuracy? Now, in this case, we know that the meter is reading a little bit below. 8.2 is a little bit below what the actual flow rate is, 8.9 liters per minute. Now, there's a variety in this case to determine what the actual flow rate was. It could have been used to fill a tank, for example, a known volume of a tank. Let's say a 5,000 liter tank, and you put out a stopwatch and you figure out how long it took to fill that tank. So that would be the known actual flow rate. We know for a fact how many liters it is. We know for a fact how many minutes it was, and you can do that calculation. So there's a whole bunch of different ways to find this known actual number. Now, when we look at the question, we have to look at which one of these measurements do you trust to be absolutely true. You know for a fact it was right. Well, in this case, we're going to call that our thought, the perfect, the known, the theoretical. The next one that we're going to look at is which one of these measurements do you hope to be true, but you know what? You can't guarantee it. Like realistically, that meter could be off. It could be high. It could be low. When was the last time it was calibrated? Was it damaged in the last X number of months? No, there's a whole bunch of factors that kick in. We're going to call that the got. Okay, what did we get when we looked at the meter? And again, that's the hopeful. That's the one that we hope to be accurate, but you know what? We're not completely, utterly confident in that number. We trust it, but when was the last time it was calibrated, for example? Now, the formula that we're going to look at is, and again, I'm going back to my high school days in terms of teaching, and I used equations that people could kind of catch on pretty easy. Got divided by thought times 100 equals percentage accuracy. Now, in this case, the got is when we did the experiment and we were not sure about how good the measuring devices were. Well, in this case, that would be like the 8.2. What did we actually read? And then the theoretical, the perfect one, we know that that's the standard to go against. And then times 100 equals your percentage accuracy. I'll plug the numbers in. And now got divided by thought is 8.2. That's the one we hope to be accurate, but we're not sure of. 8.9 is the number that we are absolutely confident with. That's the standard that we go against. And then obviously multiply by 100 equals our percentage error. And in this case, it was 92.13%. Now, depending on your situation, this might be fine. You're about 8% below. In some other instances, 8% off is, just not acceptable. If you're shooting for the moon and you're 8% off, well, you'll end up at Mars or someplace like that. Okay, the amount of acceptable accuracy will vary with each situation. Thanks for watching this math video. Please check out the other videos in this channel, put in some comments, and pass the site on to other wastewater students. Goodbye for now, and have a good day.